Okay, question 11. Okay, question 11 is asking for the refractive index of a blob. Okay, refractive index is actually, there's a formula called N. Okay, so you can recall N is actually equal to sine of the angle in the less dense medium. Okay, usually is I over sine R. Okay, so please take note, angle I must be in the less dense medium. Okay, so in this case, if you look at the formula, how do you find the refractive index based on whatever things is given here? So we must take the sine of the less dense angle. So remember to take note that all these angles I and R must be measured with the normal to the surface. Okay, so this is the normal. It cannot be an angle measured to the surface of the glass block. It must be to the normal of the glass block. So in this case, less dense is actually sine. This is air. Air is less dense than glass. So you must always take the angle in air. So in this case, the angle in air is actually sine Q over sine. The angle in glass is actually P. So can you please take note that must be less dense, so most of the time it's air. The angle in the denser medium is actually glass. So the best answer is actually, in this case, sine Q over sine P. It will be option D. Okay, so the sine of the angle between the emergent ray and the normal. So it's Q and this is P. Okay, so what about question 12? Okay, question 12 is actually another right question. Which of the marked angles is the critical angle? Okay, what do we understand by critical angle? Critical angle is actually my angle of incidence. Okay, but the condition is that this angle of incidence must create my angle of refraction, which is equal to 90 degrees to the normal. So in this case, let's take a look at where is the angle of refraction, which is 90, which is here. Okay, so this angle of refraction must be 90. So the best answer in this case, this is my angle of incidence. In this case, it's actually my critical angle. So the best answer will be option D, because this is what I will observe. The angle of refraction must be 90 degrees to the normal. Okay, what about question 13? A water wave having a speed of 0.4. Okay, this is a wave question. Okay, so wave, try to recall the formula of wave. So there's a speed v, which is equal to f times lambda. Okay, students will be very confused. What is v? What is f? What is lambda? V is actually the speed of the wave. F is actually the frequency of the wave. And lambda is actually my wavelength of the wave. So every wave will possess speed, frequency, and wavelength. So let's look at the question now. A water wave having a speed of 0.4 meter per second. So this is my v. Okay, move up and down. Okay, 5 times in 10 seconds. Okay, calculate the frequency of the movement of the cord. In this case, do we need this formula? The answer is no, because there's this information 5 times in 10 seconds. So 5 times up and down, up, up and down, up and down. You notice up and go down. It's actually one complete wave, because up and go down. So up and down is actually one complete wave. Okay, and 5 times. So 5 times is 10 seconds. So 1 time is actually equal to 10 over 5, which is 2 seconds. So it takes 2 seconds. 1 time is actually 2 seconds. See? So frequency is actually equal to the number of wave created in 1 second. So it's actually 1 over 2. So the answer is 0.5 hertz. Okay, because the time, actually 1 time is actually period. So actually the formula to use is 1 over f. So this 1 time is actually my t. So the time taken for one complete observation, okay, move up and down, is actually 2 seconds. So f is equal to 1 over t. So it's actually 1 over 2. So my answer is 0.5 hertz, which is which is option B. Okay, so this is the question for